Now that we have determined that the data supports determination of process capability, we'll use Minitab to generate the report. First, select the Six Sigma menu from within Minitab and then select the Process Report. Upon selecting Process Report, the system displays this menu. We enter 24 for the lower spec limit, 72 for the upper spec, and 48 for the target. Since the data we want to use is in one column, you will click on the single column button and place the cursor in the first field. Then click on C2, which is the column holding the data in the left window. Now click on Select, and the selected column's name appears in the single column field. Place the cursor in the subgroup size field, and click on C1, which is the column holding the month in which the data was collected. We collected samples over a full year, so there are 12 subgroups identified by month number. Since this covered the entire range of possible situations, the entire dataset may be considered as long-term data, while each of the 12 monthly samples is considered short-term. When you click on Select, that field name appears in the subgroup size field. Now click on OK, and the report will be generated. Click Next to see the results. By default, the Process Report command generates two report screens. Report 2 includes a great deal of information which may assist you in understanding the process. Let's take a quick look at this chart. This is the Process Capability Report for data entry cycle time. It contains the X-bar and S charts and other information which will be discussed in more detail in the control phase, as well as a number of factors which may be used to determine the process capability. The numerical results of this analysis are printed in a table to the right of the charts. This table contains valuable information on both long-term and short-term process capability. Click Next to see this table in detail. While various segments of the organization utilize different numbers, two of the primary values from the Process Capability Report are the Z-bench for both short-term and long-term process capability. These indicate some of the most critical factors you address in this phase. The difference between the Z sub ST and the Z sub LT is the Z shift. While the Z sub short-term reflects the capability of the process, the Z shift indicates how well the process is controlled. A process which is poorly controlled will display a larger Z shift. A Z shift of 1.5 is considered typical over the long term. For additional information on the capability indices, look for the topic in the Resources section on the left-hand menu. Click Next to see how these values are designated as Z short-term or Z sub ST. It is calculated by subtracting the target, or T, from one of the specification limits, represented here by SL. That value is divided by the short-term standard deviation. The result will be the short-term Z for that specification limit. The Z sub ST describes how precise the process is at any given moment in time. It is the value used when referring to the sigma of a process. It represents the true potential of the process technology to meet the given performance specifications. It shows what the process can do if everything is controlled to such an extent that only background noise, also known as common cause variation, is present. This metric assumes the data were gathered in accordance to the principles and spirit of a rational sampling plan. As indicated by the phrase short term, the standard deviation is estimated based on the outcome of samples within a relatively short time span. The second Z value is designated as Z long-term or Z sub LT. To calculate Z sub LT, you subtract the mean from the specification limit, and then divide the result by the long-term standard deviation to get the long-term Z-score. The Z sub LT describes the sustained reproducibility of a process. Because of this, it is also called long-term capability. This value is used to estimate the long-term process DPMO, or the PPM as shown in the Six Sigma process report. It reflects the influence of special cause variation, dynamic non-random process centering error, and any static offset present in the process mean. From this perspective, it considers all of the vital few sources of process error. It is a measure of how well the process is controlled over many cycles when compared to Z sub st. This metric assumes the data were gathered in accordance to the principles and spirit of a rational sampling plan. As indicated by the phrase long-term, the standard deviation is estimated based on outcomes sampled over a relatively larger time span. The executive summary provides a simplified view of the results. It provides the critical z-scores that will be used to make decisions in this phase, but also provides a clear picture of the process capabilities. Let's take a closer look at the process performance curves. The process performance graphs provide overall visual representation of the data. Click Next to continue. In this graph, the vertical lines represent the lower and upper specification limits for the data entry process step. The dotted line represents the short-term process capability, while the solid line represents the long-term process capability. The reason for the shift between the short-term and the long-term graphs is the expected drift of the process over time. As you can see, the defect rate is expected to increase as the process shifts. Click Next to continue. Z sub st is based on the analysis of subgroups. Z sub st is calculated based on the variation without the subgroup and assuming the process mean is centered at the target. Over time, process mean shifts and variation may widen due to so-called common causes variation. Therefore, the long-term capability Z sub lt reflects the ability to maintain Z sub st over a long period of time. A process lack of control will result in a large Z shift. Commonly, if Z shift is greater than 1.5, this is a definite indication of a control problem. Please check the glossary for definitions of common cause and special cause variation. The advantage of this analysis is to give a high-level perspective on the direction of improvements and its associated difficulties. New technology often means inventing a new process or a new product, which is perhaps more inherently challenging than optimizing current technology. This summary chart puts it into perspective. The Z sub st is on the x-axis, with the zone of average technology indicated as between 3 and 4.5 sigmas, while the Z shift is on the y-axis, with the zone of typical control indicated by a Z shift of between 1 and 2. The results are indicated by quadrants. Quadrant A shows poor control and poor technology. Quadrant B shows good technology, but a poorly controlled process. Quadrant C shows good control, but not good technology, while Quadrant D is where we want to be, with good control of good technology. The final area we will look at on the process capability executive summary is the process benchmark box. This area provides two critical pieces of information which will be used in the next step. Notice that two of the values are prominent, while the other two are faded out. In Six Sigma practice, Z sub st and long-term DPMO are reported by convention. When only long-term data is available, a Z sub lt is calculated and a Z shift of 1.5 applied to report a Z sub st. In the sigma row, what Minitab calls the potential, or short-term, sigma is the same as your ZST. The term potential refers to the result of calculating Z sub st with the process centering technique. Process centering assumes the mean can be shifted to the targeted value and the standard deviation is only associated with background variation. The Z sub st calculation may actually represent the process entitlement if new technology is required to meet project objectives. The ppm row is the same as defects per million opportunities, or DPMO. The long-term DPMO is the number we will use in Step 5. The Six Sigma product report is used when we deal with discrete data, rather than continuous data. There are three key pieces of information needed to generate a product report. An opportunity is anything you measure or test that has a chance of not meeting the requirements of a CTQ. It can be the fields on an application form, or whether a unit was delivered on time or not. If it is a measurement we choose to make that addresses a CTQ, We can consider it an opportunity. There are often multiple opportunities for a defect per unit. A defect is a nonconformity in a product. Units referred to the items, parts, subassemblies, assemblies, or systems inspected or tested. To calculate sigma, we need the number of units inspected or measured. On the next screen, we will add the data necessary to create a product capability report. Click Next to continue. We start by entering the data shown in a Minitab spreadsheet. This will be a product report for the assembly of an entire engine. In column C1, we enter the number of defects discovered. In column C2, we enter the number of units, meaning entire engines in this case, which were inspected. And in column C3, we enter the number of inspection points, or opportunities, per unit. This chart shows that there are 300 inspection points for each unit, or 300 opportunities to find a defect per unit, or 36,000 total opportunities for a defect to occur in the 120 units. You then go to the Six Sigma menu and choose the Product Report. Using the same techniques we showed earlier, we select the appropriate columns for the defects, units, and opportunities fields, and then click on OK. Minitab provides 3 outputs from this report. The Product Performance Table presents the results in numeric form. We'll look a little closer at this in a moment. The Z-bench curve provides a graphical representation of the product performance table and allows you to see how the Z-bench values compare for each characteristic. And the second benchmark graph shows you how each characteristic is doing with regard to technology. It allows you to examine the Z sub ST versus the Z shift as has been discussed earlier. This helps you determine whether you primarily need a new technology or better control. For additional information, click the Resources button on the left menu. Click Next to continue. If you look at the headings, you will see some familiar labels. The ppm, which also corresponds to the defects per million opportunities, the Z-shift, and the Z-bench. The data shown in the middle part of the report shows these factors for each characteristic tested. If there were multiple characteristics, there would be more than one line here. The bottom line shows the total for all characteristics, which in this case is the same as the one characteristic tested here.